All right, Chapter 6, Lesson 3, page 449. Our learning objective is I can evaluate algebraic expressions. So we're starting to talk about algebra here, and our vocab words are variable and algebraic expressions. And we're going to do the same thing we did in Lesson 2, except Lesson 2 was all numbers and following the order of operations, but now we're going to have these variables, so these letters that represent numbers, in our expressions. We still have to follow the order of operations. So we talked about how a variable is basically just a symbol. So it's a symbol like a letter that we use to represent a number. So a symbol, letter used to represent a number. X is a common one, right? X and Y, we've even had when we did ordered pairs. Okay, but you can use any letter. So something that's not a variable would be a regular number. So any regular number like 3, 7, 9, whatever. What is an everyday meaning for variable? So to vary. Vary, I feel like that means to change, like in a science experiment. What is the thing that you change that you're testing? So it kind of means change. So we're changing a number into a letter, or a letter into a number, and the number symbol, or the letter symbolizes a number. Jeez. My tongue's getting all twisted today when I'm trying to talk. So algebra is a language of symbols, including variables, and a variable is a symbol, usually a letter, that represents a number. Here's our real-world link. A box contains an unknown number of markers. There are 2 markers outside the box. The total number of markers is represented here. So you have this unknown number. You might represent it with X. Plus there are 2 markers outside of the box. So what if you had to find how many markers there were? Wouldn't it just be X plus the 2 outside the box? And number 1 says, suppose there are 14 markers in the box. Find the total number of markers. So you'd have to have 14 in the box plus the 2 outside the box, and that would be 16. So there'd be 14 in the box plus the 2 outside the box. That gives you your total. So that's what we're going to do. We're going to replace letters with numbers and then solve the expression. On page 450, we're just going to do simple one-step expressions. And then page 451, we'll do multi-step expressions where you have to use the order of operations. Let's read through this together. Algebraic expressions, that's one of our vocab words, contain at least one variable and at least one operation. For example, the expression n plus 2 represents the sum of an unknown number and 2. And you can use any letter as a variable. The letter X is often used as a variable. And it says to avoid confusion with the symbol X for multiplication, there are other ways that we show multiplication. So here are 3 other ways. We change the X in the multiplication symbol to a dot. So this means 5 times X. Or we put the variable in parentheses and we put the 5 times X. The 5 is right next to the parentheses, and when they're right next to each other, it means that you multiply. So this means 5 times X. Or sometimes you don't need the parentheses. Like parentheses, you usually need them if it's like 5 times X plus 2 or something like that. You do X plus 2 first and then you multiply by 5. But when it's just 5 and 5 times the variable, you can just put them right next to each other. You don't even have to have the little dot in between. And that means 5 times X. So this right here is going to be really important for you to know. Whoa, those 3 things right there. The variables in an expression can be replaced with any number. Once the variables have been replaced, you can evaluate or find the value of the algebraic expression. So our learning objective says that we're going to be able to evaluate an algebraic expression, and that just means that you're going to solve it. You're going to pop the numbers in for the letter, and solve it that way. So it says evaluate 16 plus b if b equals 25. So it'd be 16 plus 25, and that's 41. Now typically if I was solving this, I would probably go like this and solve it out that way. 6 plus 5, 2 plus 1 plus 1. So let's evaluate x take away y. X equals 64, y equals 27. So 64 take away 27. And again, you might need to do this, right? And get your 37. Now look at this, 6x. 6x means 6 times x. And if x is 1/2, it's 6 times 1/2. So you're going to have to think of this as, well, you could think of it of half of 6, because you can follow the commutative property and switch those two around. Half of 6 is 3. Or you could think of it as fractions. 6 times 1/2 and multiply across 6, 2, and then simplify. All right, so you're going to have to show a little bit of work. It's not just all, oh, I magically know it, like in the examples. All right, let's do this here. A is 6, B is 4, C is 1/3. Let's try it. This first one's really simple. A plus 8, so it's 6 plus 8. And that would be 14, right? All right, now A is 6, B is 4. So it'd be 6 take away 4. All right, that one's another easy one. Now do multiplication. A times B. So 6 times 4. That could have been written like this, by the way. So 6 times 4, that would be 24. And now we've got that fraction here. So 9 times C. 9 times 1/3. So you can think of that as 1/3 of 9, or 9 over 1 times 1 over 3. So 3 goes into 9 3 times. So it's like 9 divided by 3, 3 divided by 3. Oh, you know what? Sorry, it's really hard to write on that little section right there. So 9 divided by 3 is 3. 3 divided by 3 is 1. So that's 3. Did you ever think of this? Remember when we simplified this way? 3 divided by 3 is 1. 9 divided by 3 is 3. So 3 times 1 is 3. 1 times 1 is 1. So you got different ways that we've learned throughout the year that you can use on this to show your work. So that answer is 3. Okay, so these were just one-step expressions. Now we're going to do the same thing but multi-step, which means to evaluate multi-step expressions, we have to replace each variable with the correct value and then follow the order of operations that we went over in lesson 2. So here, 5t plus 4, t equals 3. So 5 times 3 plus 4. You do multiplication first, 5 times 3, and then the addition. Look at this nasty guy right here. 4 times x squared, or x to the power of 2. X is 1/8. So 4 times 1/8 squared. They put it in parentheses so you don't get confused and think it's just 1 squared. So we have to do that 1/8 squared, or 1/8 to the power of 2. Multiply across, multiply across. That's where they got the 1/64th. And then you have to do 4 times 1/64th. So look at this, 4 over 1, 1 over 64. Now, the question is, can you simplify that? So what's 64 divided by 4? You can do that. 64 divided by 4 is 16. So 4 divided by 4 is 1. 64 divided by 4 is 16. That's where they got 1 times 16, the 1/16th right there. All right, let's fill in the blanks for example right here, number 6. Evaluate 10a plus 7 if a equals 1/5. So 10a would be 10 times 1/5 plus 7. So we have to do 10 times 1/5. 10 times 1/5. So let's make them both fractions and multiply across. Look at 5 divided by 5 is 1. 10 divided by 5 is 2. 2 times 1 is 2. 1 times 1 is 1. So there's your answer, 2. 10 times 1/5 is 2. You could also think of this as 1/5 of 10. So then 2 plus 7 is 9. Let's do these E, F, and G problems here. D equals 12, E equals 1/3. So we need to do 2D take away 5. So I'm going to do E right here. All right, 2D take away 5. So that's 2 times 12 take away 5. And 2 times 12 is 24. Take away 5. 24 take away 5. 19. So E is 19. What about F? 50 take away 3D. So 3 times D, and D is 12. So this is 50 take away 3 times 12. All right. So what is 3 times 12? 36. So it's 50 take away 36. Now I like to count up. 36 plus 4 is 40. Then plus 10 would be 15. So that's going to be 14. Now some of you might like to do that on the side, like 50 take away 36 and borrow. So whatever you like to do works. Okay, that's 14. What about this one? I'm going to do this one, G. Let's do G right here. So G is 9e squared, which would be 9 times e to the power of 2. So 9 times 1/3 to the power of 2. We have to do exponents before we multiply. So what's 1/3 times 1/3? 1 times 1 is 1. 3 times 3 is 9. So this is 9 times 1/9. So I'm going to do 9 over 1 times 1 over 9. And look at that. 9 divided by 1, 9 divided by 1, 1 over 1. So that's 1. Interesting, huh? Cool. All right, let's go to the last example. A little story problem here. Example 7 on page 452. All right, Khalil is wrapping a gift for his brother's birthday. The box has side lengths that are 1/2 foot. So here's the box. Each side is 1/2 foot. Use the expression 6s squared, where s represents the length of a side, to find the surface area of the box he is wrapping. Write your answer in square feet. So there are 6 sides to the box. Each side of the box has an area of 1/2 times 1/2, which is 1/2 squared. So we did the exponent first. 1/2 times 1/2 equals 1/4. 1 times 1, 2 times 2. Then 6 times 1/4. So 6 times 1/4. You can divide both of those by 2, which gives you 3 times 1 and 1 times 2. So 3/2 is 1 and 1/2. 2 goes into 3 once, and then there's 1/2 left over. All right, and we don't even get to do another example. We are moving right on to guided practice. Oh, so the answer, by the way, is 1.5 square feet. That's the surface area of all 6 sides. Hey, make sure that you partner up here for the guided practice. All right, guided practice number 1 through 7 is what we're going to do. Some of these go super duper fast, by the way. So it looks like more than normal, but it's super fast. So you are going to use M is going to equal 1, Z equals 9, and R equals 1/6. You're going to plug in those numbers for those letters in 1 through 6 and solve the problems. So do that, pause the video, check it, go on to the next one. Here we go. 3 plus M, where M is 4. So 3 plus 4 is 7. Z, take away M. Z is 9. M is 4. So 9 take away 4 is 5. Hey, make sure that you're showing your work by just showing what you plug in for each letter on those. What about 12R? That would mean 12 times R, and R is 1/6. So I would do 12 over 1 times 1 over 6. I'd simplify here. 6 divided by 6 is 1. 12 divided by 6 is 2. 2 times 1 is 2. 1 times 1 is 1. So that's 2. Okay, 4M take away 2, and M is 4. So this is 4 times 4 take away 2. 4 times 4 is 16. 16 take away 2 is 14. What about 60R take away 4? R is 1/6. So 60 times 1/6 take away 4. Let's talk about what 60 times 1/6 would be. 60 over 1 times 1 over 6. We can divide by 6. That's 1. 60 divided by 6 is 10. So 10 times 1 is 10. 1 times 1 is 1. So 60 divided by 1, or 60 times 1/6 is 10. Take away 4. And 10 take away 4 is 6. All right, number 6. 3R squared. 3 times R squared. So 3 times 1/6 squared. So what's 1/6 squared? That's 1/6 times 1/6. 1 times 1 is 1. 6 times 6 is 36. So this is 3 times, this right here was 136. So let's do that. 3 over 1 times 1 over 36. Okay, now 36 can divide by 3. Because 3 times 12 is 36, and 3 divided by 3 is 1. So 1 times 1 is 1, and 1 times 12 is 12. So 3 times 136 equals 1/12. Sweet. One more problem. The amount of money that remains from a $20 bill after Melina buys 4 party favors for P dollars each is 20 take away 4P. So she had a $20 bill. She bought 4 party favors. How much is left? You have to subtract. And they want you to find the amount remaining if the party favors cost $3. So we're looking at 20 take away 4 times 3. 4 times 3 is 12. 20 take away 12 is 8. So the amount remaining, $8. Now let's practice some of these on your own. Moving on to independent practice. Practice, you're doing 1 through 9. So let's circle those. And M equals 2, N equals 16, P is 1/3. And for this, a paper recycling bin has the dimensions shown. Use the expression S to the power of 3, where S represents the length of a side, to find the volume of the bin. So this is that S cubed. Remember when we talked about finding volume of a cubic shape? So write your answer in cubic meters. So S cubed, and it's S is going, a side is 1/2 of a meter. All right, go ahead and do the independent practice. All right, let's check the independent practice. So m equals 2. 2 plus 10 is 12. N equals 16. 16 divided by 4 is 4. M is 2, N is 16. 2 plus 16 is 18. 6 times M. So 6 times 2, take away 1. That's 12, take away 1 is 11. Then you have 3p. So 3 times 1/3. And 3 over 1 times 1 over 3 equals 1. All right, 12p. So 12 times 1/3. 12 over 1 times 1 over 3. Simplified that, you got 4 over 1, that equals 4. Or you could think of this as 1/3 of 12 or 1/3 of 3. 12m take away 4, so 12 times 2 take away 4. 12 times 2 is 24. 9p squared, so 9 times 1/3 squared. 1/3 times 1/3 is 1/9. And then 9 times 1/9 is 1, or 1/9 of 9 is 1. For number 9, a paper recycling bin has the dimensions shown. We had to do 1/2 times 1/2 times 1/2, or 1/2 to the power of 3. 2 times 2 is 4. 4 times 2 is 8. So 1 times 1 times 1 is 1. So it's 1/8 meters cubed. Time for the reflection. So here's the lesson 3 reflection for I can evaluate algebraic expressions. Label the expression as numerical or algebraic. So one of these is numerical, one of these is algebraic. In number 2, an algebraic and numerical expression are different because an algebraic expression contains what? However, they're similar because in both we have to evaluate the expression by following the blank of blank. In number 3, in order to not confuse the multiplication sign x with the variable x, what are 2 other ways to write 5 times n? Evaluate the following algebraic expressions. So E equals 1/4, F equals 9, and G equals 5. Show your work. So actually show what F is and what G is before you give the answer. All right, you can do it.